So in the last lecture we introduced Laplace transformation and sufficient condition for Laplace transformation, and after that we considered two properties of Laplace transformation, namely one was linearity property, and another it was first shifting theorem. Okay, these two results we just defined in the last class. So you can refer to the last video where we have covered up to this part. Now we are continuing from that. So linearity property and first shifting theorem, combining these two concepts, we can have many questions. So those questions we'll discuss in the subsequent parts as well. Now see a few basic Laplace transformation we'll try to find. For example, if I write, suppose find Laplace transformation, find Laplace transformation of sine hyperbolic at. Okay, this function, for example, we can take this one. Okay, or suppose this is question number 1. Find Laplace transform of e power at. Okay, then t power n already we discussed in the last lecture. Now suppose I want to get Laplace transform of t power 3/2. Okay, so here one by one we'll see the solution. Laplace transform of sine hyperbolic t. Then suppose fourth one is cos at. I want this one. Okay, or suppose instead of cos at I can have this one particular value, suppose cos 2t. I want this. Okay, so one by one we'll see. So Laplace transform of sine hyperbolic t. So ft is equals to sine hyperbolic at. This is the question. Okay, the second question, it was Laplace transform of ft is equals to e power at. So for this one, Laplace transform of e power at, if I want to do this, so see the solution. Laplace transform of ft is equals to Laplace transform of e power at. So that is given by, if you just apply that formula is what? Integral 0 to infinity e power minus st ft, so e power at dt. Alright, so this is nothing but integral 0 to infinity e power minus s minus a t dt. So this is nothing but e power minus s minus a t by minus s minus a, provided s minus a is greater than 0. This should be given. So 0 to infinity. If you put upper and lower limit, you will be getting 1 by s minus a. So Laplace transform, this is one of the formulas, that Laplace transform of e power at is equals to 1 by s minus a. This is one of the formula. Now Laplace transform of e power at, this one. Okay, so now consider this question. See, I want to find that Laplace transform of sine hyperbolic at, and you know that sine hyperbolic at, it is nothing but e power at minus e power minus at by 2. So from here, Laplace transform of ft, that is Laplace transform of sine hyperbolic at, where we can use this formula, that is e power at minus e power minus at by 2. Okay, now see, we can apply linearity property. By linearity property, what we have, see, half Laplace transform of e power at minus Laplace transform of e power minus at. This is by linearity property. Now see what you have. Just now we got this result, Laplace transform of e power at. This result just now we got. So we can apply this result, that here 1 by s minus a, 1 by s minus a (1 by s minus a) minus 1 by s minus of minus a, that is s plus a. So half, if you do this one, this calculation properly, then you have, see, s square minus s square. So here what you have, 2a, here you have half, so basically s square minus s square, that is Laplace transform of sine hyperbolic at, Laplace transform of sine hyperbolic at, it is given by a by s square minus s square. This is another standard formula. Okay, so basically you need to remember this formula. Okay, so Laplace transform of sine hyperbolic at. Next it was, see, third one, Laplace transform of t power 3 by 2. See, third one, ft is t power 3 by 2. In the last class we covered one formula, that is Laplace transform of t power n, that is gamma n plus 1 by s power n plus 1. This was one of the formula, we studied it. Okay, so this is one of the formula, standard formula, but we covered in the last class. So now see, we can apply this formula, and here what you have, see, Laplace transform of t power 3 by 2. So gamma 3 by 2 plus 1 by s power 3 by 2 plus 1. Alright, so you know that one formula, that is gamma n plus 1, it is nothing but n gamma n. This is one standard formula of gamma function, that is gamma n plus 1, it is n gamma n. So if you apply this formula, so immediately 3 by 2 gamma 3 by 2 s power 5 by 2. Now here this 3 by 2 gamma, this 3 by 2 can be written as half plus 1, so that is s power 5 by 2. Alright, so 3 by 2 half gamma half by s power 5 by 2. So gamma half value, it is square root of pi. So square root of pi, that is 3 square root of pi, here 4 s power 5 by 2. Okay, this is the answer for Laplace transform of t power 3 by 2. Now next question, it was cos 2t, Laplace transform of cos 2t. So for that, here I would like to give one understanding, that this is, I think, question number 4. So for that we'll try to find what is Laplace transform of cos at and Laplace transform of sin at. This thing we'll try to find. Okay, so you know that Laplace transform of e power iat, if I write this one, this is nothing but, as per that previous formula, e power at, it should be s minus I a, as per that previous formula. Okay, and here the complex conjugate, we can multiply the numerator as well as denominator. So s plus ia, and here s minus ia into s plus ia. So here what you have, s plus ia, here s square plus s square. So e power I at, that means one formula, you should know this formula, that e power I theta, it is cos theta plus I sin theta. This is one of the standard formula Now we are going to apply this formula here. So if you apply this formula, so immediately what you have, see, Laplace transform of cos at plus I sin at. Now apply that linearity property. So if you apply the linearity property, it becomes Laplace transform of cos at plus I times Laplace transform of sin at. Okay, so here see, s by s square plus s square plus I times a by a square plus s square. So if you compare the real part and conjugate, real part and complex part, real part is equal with this and complex part it is equal with this. So immediately you can have this formula, and that is Laplace transform of cos at, it is given by s by s square plus a square, and Laplace transform of sin at, it is a by a square plus a square. This formula, it is one of the classical formula of Laplace transformation, that is Laplace transform of cos at and Laplace transform of sin at. Now based on this, what you had, just think, you had this question that what is Laplace transform of cos to t. So just apply this formula, that is s by s square plus 2 square, that is s by s square plus 4. This will be the answer. Okay, so these formulas, whatever it is here in terms of box, you should know this formula, and you will get all these formulas in the form of a table. So there all these formulas you will find. So now another question I can give, suppose I have one function. Let me go to the next slide. Yes, so suppose I am writing this question, find Laplace transform of one function, it is given ft. Here the values are 0 when 0 less than t less than 1. It has the value t when 1 greater than t, then 4, and 0 when the t value it is greater than 4. That means basically if you try to draw the graph of this function, it looks like this. See, suppose this is t axis, that is this is ft axis. Okay, so here 0 to 1, here 1 to suppose 4 here. Okay, so 0 to 1 the function value it is 0. Okay, 1 to 0 to 1 the function value it is 0. Here 4 onward the function value is 0. So in between 1 to 4 the function ft is equals to t. So ft equals to t, it is the value. So it looks like this type of function. Okay, looks like this type of function. Yes, so you can see the function it is piecewise continuous here, piecewise continuous. Now see, piecewise continuous function, so we can find Laplace transformation, not a problem. So in that case, see how we can find the Laplace transformation. See, Laplace transform of ft, that is given by integral, we know that 0 to infinity e power minus st ft dt. In such cases, when the function it is given in terms of this piecewise form, so in that case 0 to that interval you need to consider, 0 to 1 it is given, 0 to 1 e power minus st, the function value is 0 dt, plus 1 to next one, 1 to 4, that is 1 to 4 e power minus st, and the value it is t dt, plus integral 4 to infinity e power minus st 0 dt. First and third part will give you 0. So remaining part, that is 1 to 4 e power minus st into t dt. So if you apply integration by parts, immediately you will get, I think I have covered this question in the last class as well. So anyway, you can try this type of question if you apply integration by parts, you will get this one. Verify this one by integration by parts. Okay, so this type of question you should practice. Now next property I can discuss with you. Next property, it is first two property already we have covered, linearity property and first shifting theorem. So next property, it is change of scale property for Laplace transformation. So it says that suppose if Laplace transform of ft it is fs, then Laplace transform of f of at it is 1 by a f of s by a. So this is first this is change of scale property. Okay, so if you want you can go through the proof. See, proof, I'm just giving you the outline. See, Laplace transform of f of at, Laplace transform of f of at, this is given by integral 0 to infinity e power minus st f of at dt. Now here we need to put the substitution at is equals to u, so that a dt is equals to du. So the limits will be same, that is 0 to infinity e power minus, here you can see this t, you can write u by a, which becomes s into u by a f of u du by a. This form you are going to get. So 1 by a integral 0 to infinity e power minus s by a u f of u du. Got it? So this is nothing but, say, we know that f of s means integral 0 to infinity e power minus st ft dt. We know this. Okay, so f of s by a means here in place of s what you have, 0 to infinity e power minus s by at ft dt. So that's what here you have. Okay, so it is nothing but 1 by a f of s by a. So this is Laplace transform of f of at. Okay, this is called change of scale property. Okay, change of scale property. Now we can have one or two questions from this part. Find Laplace transform of e power minus t f of 3t, that is e power minus t f of 3t, where Laplace transform of ft it is given as e power minus 1 by s by s, suppose. Okay, that means you need to find Laplace transform of e power minus t f of 3t. This one you need to find, where Laplace transform of ft, Laplace transform of f of t, it is given as this one. Okay, so see, this one it is given in the question. So how to proceed with the solution? See the solution. So Laplace transform of ft, it is given as e power minus 1 by s by s. So immediately Laplace transform of f of, see here what is the requirement, f of 3t. So I want this one. So as per this formula, it should be 1 by a, that is 1 by 3 f of s by 3. So what was that fs given? This is the given fs. So just write it according to that, 1 by 3 e power minus, in place of s you are going to write s by 3. So here 3 by s and here s by 3. So s, here 3. So basically you are going to get e power minus 3 by s by s. Okay, this is Laplace transform of f of 3t. So this is your new, this is new f of s. Now Laplace transform of e power t f of 3t, this thing you need to find. So here this is the new fs. So by first shifting theorem, f of s minus a value it is minus 1, so s plus 1. So here what you have, see e power minus 3 s plus 1 by s plus 1. This is going to be the final answer. So here what we applied first shifting theorem, and here we applied change of scale property. Okay, so this type of questions you should practice where the properties are directly involved. Okay, so this is one of the standard question that I considered here. Now another question I can give you, that if you have any query or comment, then you can drop in the comment section as well. Now write down next question. And next question, find Laplace transform of 3t power 5 plus 4 e power 5t minus 3 sine 60 multiplied with e power 2t. This is the question. See, I'm just giving you the hints for this solution. See, Laplace transform of 3 t power 5 plus 4 e power minus 5t minus 3 sine 60, here e power 2t. So this one you need to find. So Laplace transform of 3 t power 5 e power 2t plus 4 e power minus 3t. Just try to simplify it. Okay, 3 e power 2t sine 60. Now apply linearity property, so it becomes this t power 5 e power 2t plus 4 Laplace transform of e power minus 3t minus 3 Laplace transform of e power 2t sine 60. Okay, now see here, you know that Laplace transform, the formula, just recall that formulas, t power n gamma n plus 1 by s power n plus 1, and corresponding to this Laplace transform of e power at t power n, in place of t power n already you had f of t. Okay, so by first shifting theorem it should be n plus 1 by s minus a power n plus 1. So just apply this one here in the first term. So the first term, it becomes 3 t power 5. So gamma 5 plus 1 by s, here e power 2, a value it is 2, 5 plus 1, that is 6. Okay, next is what? Next, Laplace transform of plus 4 times Laplace transform of this part. So immediately here you can write s minus of minus 3, that is s plus 3 minus 3. Again the same concept. Okay, so here you have the formula, that is Laplace transform of sine at. Laplace transform of sine at. Just go back to the previous slide. Laplace transform of sine at, already you got it. That is a by this formula, a by s square plus s square. So this is a by s square plus s square. Now here you can see e multiplied. Again from here, first shifting theorem, that is Laplace transform of e power, suppose here e power bt sine at. So here what you have, a by s minus b square plus s square. So here you can apply this and immediately you will get the answer, that is a value it is 6. So 6 by s minus 2 square plus. Now your next work will be to simplify this one. Okay, so what is there? 3 gamma 5 plus 1, gamma 5 plus 1, that is 5 factorial. You know this formula, that is if n is integer, then gamma n plus 1, it is nothing but n factorial. 5 factorial by s minus 2 power 6 plus 4 s plus 3 minus 18. Here you have s minus 2 square plus 6 square. That will be the final answer for this question. Okay, so likewise we can solve the questions using the relevant properties. Okay, so in the next lecture we'll discuss few more properties and relevant application we'll see there. Okay, by that time should practice this type of question from Laplace transformation using the fundamental properties and the definition as well. Okay, so we'll see in the